Hi, my name's Amy. Welcome to the Seattle Children's Museum's Fundamentals of Science. This is our SCM at Home series, and from my home to yours, let's get started. Today, we're going to work with catapults. And a couple of the ingredients that you could find handy would be some craft sticks. You could try some skewers if you happen to have those. Just be really careful with the pointy ends, okay? I have a bunch of rubber bands here. Some of these at my house are not so fresh, so I'm going to be real careful. Just make sure that they are not so brittle that they fall apart. If they do, I'll go on to another one. I've got some garden string in case I want to use that. I've got a couple of different caps that I can use, as well as for baskets for my catapult, as well as some things to actually fling. I've got cotton balls here, which are nice and safe. And I also have the preferred candy of the day here, which is jelly beans. So we'll see how far those go. All right. So I made a catapult to get us started, but this is by no means the only kind of catapult to make. So please today use this as a starting point for some of your experiments and things that you can do. One of the things that I like to do to get started is to write down some big questions that I have for this experiment. So some of the things that I'm wondering are how do I make the best catapult that will go the farthest? I'd also like to see if I can not only go super far, but if I can be accurate. So if I were a knight storming a castle, I would want to make sure that this could land where I want it to go, which is not always an easy thing. So I'm going to see if I can make it as accurate as possible. It's a challenge that I have for myself. I'm going to be looking to notice things about this. So I'll be comparing and see what design things turn out better than others. So maybe I have some really great ideas. Maybe I have some ideas I thought were going to be great and they turn out not to be so much. So, but we're in this together. We'll do some experimenting. All right. So for this one, we have not much of a base, but it can lay flat. And then we do have a springy thingy, technically called a lever, right? This is where potential energy, which is coiled up in the spring of the wood there, and it's compressed, squished down. And when I release it, that potential energy becomes kinetic energy, moving energy. Let's try that with a cotton ball. All right. A lot of our simple toys that we could make at home use the ideas of potential and kinetic energy. So a lot of things you can work with there. All right, I'm going to help you build one that's similar to this, but I want to change some variables that are some things about this so that we can compare. All right, a variable would be one thing that I want to change. And because I want to be a good scientist, I'm going to change one thing at a time and then do my experiment and notice what happens, all right? And I'm going to write down my results too. You can do that or you don't have to. All right, so this part here, which is wedged in between, for this one, I used 3. So I thought that was a good place to start. But for the next one, I think I want to go a little bit higher if I can. So I've put 4 together here. And then there's this piece, that's the cross section, and then we have this piece that becomes the arm, which launches. I also call it the springy thingy. Okay. Let's see what we get going on here. I wonder how springy it's going to be. I also wonder how tight it has to be. Or loose. I don't know. Then I put that piece in there. Now this is going to wobble all over the place if I don't secure it. See, it's already doing that. So I'm going to do that with a crisscross applesauce with my rubber band. And then I'll talk a little bit about the basket that I put on here because I did that ahead of time. I confess I tried to do it and then immediately make a catapult and it had to dry. And then I decided, why don't I put something in to make it even more sturdy? So I'll go through that with you and we'll see what you think. All right. There we go, crisscross applesauce. If it's a little crooked or not, it moved on you, just move that around. You can push that down. Okay, let's compare. Which one do you think is wider? What effect do you think that's going to have? Let's find out. All right, now here's a tip about this. I put it on, I used the glue stick, and it worked fine with this one, and it stayed on, but this one kept falling off. So I ended up just putting a little piece of tape to reinforce it there. Whatever you have, that's what we're going to go for. All right, now we're going to compare. And a good scientist wants to be able to replicate their study, and other scientists are going to want to say, how'd you do that? And they're going to want to tell them how they did it and then be able to repeat it. So that is an important thing for scientists to be able to do, is share their information. So make sure that you're consistent, and that's also another good reason why I do one thing at a time, change one thing at a time. All right. All right. Right away, I noticed that this one went farther. It also went higher. So that's pretty cool. What if I wanted to change something else about this one? If I wanted to change another variable, what could I change? I've got this base here with this space, right? I could try to make that go higher so it was even farther, but I think it's a little stiff and it's going to be harder and harder to do that without breaking my popsicle stick. What happens? I wonder what would happen if I made this arm on my catapult longer. Let's see. All right, so I'm going to try that. I'm going to take this off. This happens a lot in science too, where scientists and engineers look for ways to solve a problem or design something, and they make changes as they go along. So that's why we get different versions of something. We might solve one problem, we might make another. So in this case, I've got this basket. If I want to use a different one, I can. Or I can try this one. Let's do this. Let's save this one for later. I'll keep this one because I like it. And we can go back to trying it. But I think I can do something better. All right, another one. What if, I think I could put these together and I can make a longer arm. And I'm wondering if that has any effect on it. I'm not sure, but I'm hoping that a longer arm with more potential energy to lift the springy thingy, I wonder if it will make it go farther. So I'm just going to hold that together with the rubber bands because that's what I have. Speaking of what I have a cap right here. I think I can use that. Okay. And I learned from my last one that it's helpful to have a little bit of a space to put your thumb so that you can give it a good thwack. Alright, I'm going to put 2 pieces of tape on there. Okay. Well, now I could put those together just like the other one was. Remember, I'm checking those rubber bands because they're kind of old. Remember, we're working with whatever we have at home. I wonder also if that means I need some more this way. We'll try first things first. Okay? All right, so let's see where the third one can go then. We start right here. Even farther. Great. Cool. All right. If I want to try a different variable, I'm wondering about my sturdy base. A couple of different directions I could go. I'm thinking I could make that a little bit longer. See if it makes it easier, or here's my challenge for you. Take something that you could build from or make a pyramid type shape, something with a really wide base that you could use to be super sturdy and launch this. It could be that you just take the box and you tape it over. Maybe you actually build up from the box to make something. I don't know what your creation is going to be, but I'd sure like to find out. So please send us your creations. I'd love to see what you're doing through Instagram, a tweet, or Facebook. All right, see you there.